Hi, my name is Ramesh Chalmal Setti. I belong to Group 5. Today we are developing an AI model using machine learning. We chose our topic employee attrition model for healthcare. We chose this topic because nowadays it has become quite common. Like if an employee joins in a healthcare sector, he is quitting the job very soon. So there could be many reasons why he is leaving. So we thought we use machine learning as a tool to find how the employee is leaving this organization. To develop an AI, we have taken the data from Kaggle.com. This data is from an real HR data. Accurate predictions can help retention efforts towards high attrition risk in employees. So for the developing AI, we have taken a data set of 1676 rows and 35 attributes. 35 attributes which include employee age, employee educational status, employee hourly rate, employee is whether the employee is over 18 or below 18, and how the employee is doing is whether the employee is doing overtime and shift he is working. Like we have taken 35 attributes for the developing of our AI. We are having 34 attributes. We are using decision tree. Decision tree is an supervised learning technique that can be used for both classification and regression problems, but mostly it is preferred for solving classification problems. In this, we are using CAT algorithm, which stands for Classification and Regression Tree Algorithms. We are implementing a decision tree. The main issue arises that to select best attribute for root node for and substitute nodes. To solve, we are using attribute select measure or ASM. By this measurement, we can select attribute for the nodes. There are two popular techniques for ASM, namely information gain and Gini index. For our attrition problem, we are using information gain. In information gain, it is a measurement of changes in entropy after segmentation of data based on an attribute.
Name is Manthan Sani and I'm continuing this PPT and my topic is random forest. Random forest is the popular machine learning algorithm that is used for both classification and regression tasks. It's a learning method that combines like multiple decision trees to make one accurate prediction. Each tree is forest is trained on a different subset of data and uses random subset of features, reducing overfitting and improving generalization. Um, and we have used this random forest and we got the score of precision score. We have 0.873508 and recall is same as well. Accuracy is same and kappa score is however is different, is 0.387903 and F1 score is 887828. And at the bottom we have is the confusion metrics. So an actual one means like this is actually happened. Predicted zero means the system doesn't predicted it. So if we see like actual one and predicted one is 18 and whereas predicted zero and actual zero is 354, which mean the model is working and actual reading was 354 and where it predicted was also zero. And it tells the accuracy of the model. Whereas if we talk about 44 and 3 values, this is something like our model predicted and which was 3, but in actual there was nothing. And our model predicted 44 and in actual, sorry, model was actual was 44, but the model predicted nothing. It was 0. It didn't predict anything. The accuracy is good because the values which are predicted and was present in actual are equal. So that's why a model is successful. Piece is a popular and a simple machine learning language. It is used for classification basically, and it is based on the Bayes theorem, which where the naive in its names come from. And the basic idea of its working is like it has Bayes theorem that calculates the probability of a particular event happening based on prior knowledge of condition. It has conditional independence, which in which that it assumes all features used to make a classification decision are independent of each other. Third one is training. It learns from labeled data, calculating the probability of each feature occurring for each class. We formed naive Bayes and we got all 6 values of precision score is 0.436754. Recall score, accuracy score, and F1 score is all same. whereas the kappa score is 0.099073. And in the end, we made a confusion matrix, which tells us like our model is successful as well, because in actual and predicted, it is the reading is 55. It means like actual was it was 55 in actual, and predicted was 55. Like 55 employees will be attrition. The attrition in 55 employees will be predicted, and actual it was correct. Whereas in another one is in predicted 0 and actual 0 was 128, and which means like in actual there was 128, which was not in favor of attrition, and predicted prediction was also good. If we talk about the other analysis, that is in which our model didn't predict it and in actual was the reading, which tells us about like our model is accurate and it's working. Let's move on to the next method, that is, or we call convolution neural network. It's a specialized type of artificial neural network designed for processing and analyzing the structured grid-like data such as image and video recognition, and also object detection and facial recognition. Here are some of them are the key components that are used, like convolution layers. They automatically learn the hierarchical patterns and feature from the input images. The pooling layers, often like average pooling, downsampling the feature maps, reducing their spatial dimension. This helping in complex computation. And third one is the activation functions, that is non-linear function like rectified linear unit, and which is applied to introduce non-linearity into the model. And the fully connected layers, after several convolution and pooling layers, CNN often have one or more fully connected layers for making final prediction. Likewise, it has convolution filters, which specify features such as edges, textures, stride and padding, dropout, and pre-trained models. And in this, however, in this one, we have used three convolution ID, and total of 1886018 parameters were used. Model got fitted in 40 approach with early stopping mechanism. And we made the confusion matrix as well, which is displayed in the PPT, which says like the actual and the predicted label was 35, and however the attrition for predicted and actual were 0 at 342, which shows our model is accurate and is working. Thank you. And for the next slides, my friend will discuss about that. Thank you.
Everyone, this is Abdul Kazim Mohammed. Now I'm going to take over the presentation from Anson Saini. So now we're talking about the accuracy of various models. As you can see, the graph here, we've got like four different methods, like models, which is decision tree, random forest, naive Bayes, and CNN. And on the left side, you see the accuracy. So the highest accuracy we have here is 89.98% for CNN, and followed by Random Forest, which is 88.78%, and the next would be Decision Tree, 87.35%. The least one is Naive Bayes, which has the very less accuracy, which is 43.68%. Now, let's say the trade models were used to predict on the unseen test data. Metrics like accuracy, precision, recall, F1 score, and coherence kappa quantified model performance. Random Forest performed best with the accuracy of 80% and F1 score of 81%. As well, the backed trees effectively handled the imbalanced target variable. Logistic regression and SEM also had decent performance. We're coming to the conclusion. So, six supervised learning models were trained on the pre-processed data, which is logistic regression, decision tree, random forest, SVM, KNN, and knife bias. and hyperparameters like an estimators and keyword tune using grid search cross validation. Also, we've got these bullet points here, which are the major conclusion points. Now, you see the ability to predict attrition is important in healthcare industry. The next one would be performed the exploratory data analysis, and we did data preparation was done like on the encoding and dummy variables. There was four models as decision tree, random forest, naive bias, and CNN, which were fit on the existing data. The next one would be the performance metrics and confusion matrix, which was plotted for each model. And based on the accuracy, the CNN was performing better, followed by random forest. And the next would be the model can be operationalized and improved further based on newer data. Also, we saw that the support vector classifier was the best model for this purpose, followed by the precision score and random forest. Thank you. That's it. Guys.